as you work these problems, be thinking about combining like terms. In order for us to add or subtract, we have to have the like terms, which means that the variable is the same and the exponents are the same. So that's required for us to add or subtract. Multiplication is a different story, but adding and subtracting, make sure they are like terms, same variables and exponents. And a hint here, as you combine like terms, the reason why the exponents have to be the same is because when we add and subtract them, the exponents are going to stay the same. All right, so for that first one here, we're going to go ahead and work that one out here, see what we can and can't combine. I need those like terms. We got our negative 8x squared and we have our positive 2x squared. Those are the only ones that are like terms here. They're the only ones that have the same variables and the same exponents. So those are the ones I can add. Nothing else is going to change. So the 5x cubed, not going to change because there's nothing else like it. Now I'm going to go ahead and do the minus 8x squared plus 2x squared. So that means I got to do negative 8 plus 2. Negative 8 plus 2 is going to give us a negative 6. So that's minus 6x squared. Remember, the exponent stays the same, so it's still going to be x squared. And then the minus 5, again, that one didn't have any like terms, so it stays the same as it was. All right, now taking a look at number 2. When doing number 2 here, we are raising it to the power of 3. Now notice we're raising everything to the power of 3. So I'm going to end up having to do the 2 to the power of 3, and I'm going to have to do the x to the 5th to the power of 3. A lot of people forget about bringing the 2 to the power of 3 along the way. So 2 to the power of 3. What is 2 to the power of 3? 2 to the power of 3 is 2 times 2 times 2, which is 8. So 2 to the power of 3, or 2 cubed as we often will call it, is 8. And then we do x to the 5th to the power of 3. Now when I have a power to a power like that, that's the one that tells me to multiply the exponents. So I'm going to end up with x to the power of 5 times 3, which is 15. So that ends up giving us 8x to the 15th. All right, then for number 3, we got the parentheses, and we got to get rid of the parentheses. In this case, that's going to mean just using distributive property. So I'm going to have to multiply the x squared by the 4x, and I'm going to have to multiply x squared by the minus 10. So x squared times 4x, that's going to give me 4 times x to the power of, now when I multiply x's, I add their exponents. And in this case, I'm doing x squared times x to the power of, what's the exponent on the x?
1.
1. Yep. If we don't write the exponent in, it's a 1. So that's the same as 4x to the 1. So when I multiply those, I'm going to do x squared times x to the 1. That's 2 plus 1. It ends up giving me 4x to the 3rd power. Then the minus is still there because nothing's changing the minus. And now I have to do x squared times 10. Well, there's no number that's going to change the 10, and there's no x that's going to change the x squared, so it's just 10x squared. Okay, so for now, for number 4, I'm going to start by looking for the like terms because there's a lot of adding and subtracting being done here. So first up, I start with an x to the 6. So I'm going to start by looking for others that are x to the 6. And I do have one other here that's x to the 6. So I'm going to go ahead and start by adding those together. So I got x to the 6 plus 2x to the 6. One thing I want you to remember here is that x to the 6 at the start, that means that it is 1x to the 6. So when I add these together, I have 1x to the 6, and I'm adding 2x to the 6, so I should have a grand total of 3x to the 6. And remember, they have to be like terms with the same exponents because the exponents stay the same. All right, now I'm going to look at other terms. So next up I have x squared terms. Okay, notice this is a great technique, by the way, if you're dealing with polynomials and you're trying to combine all the different like terms. Use different ways to mark each of the different types. So like I'm putting boxes around all the x squared terms. It makes it a little bit easier to backtrack and find them all and make sure you took care of all of them. So thankfully in this case, all the rest of them were x squared terms, and so those will combine. So I'm going to do negative 3 plus 1. What's negative 3 plus 1? It's negative 2. Okay, and then I do the negative 2 plus 2 on the end, and negative 2 plus 2 is 0. 0x squared is 0, because 0 times anything is 0. So rather than writing in like 0x squared or something like that, I don't need to write in plus 0. So actually that's our final answer right there. It's just 3x to the 6th. Because all the x squareds canceled out, and so they went away. All right, and finally in number 5. There's two different ways you can do number 5. You can either distribute the 3x into all 4 terms at the start, or you can start by combining like terms at the start, because we have a 5x and a minus x. I like to combine the like terms first, just as a matter of my own habit, so I'm going to go ahead and do that first. So the 3x, I'm not doing anything with it yet. The x squared is unchanged. Now I do 5x minus x. I have 5 x's, I take away 1x, I'm left with 4 x's. And then the plus 1 there. Because again, I'm not distributing yet. My next step, which I'm going to do now I'm going to go ahead and distribute. So I'm going to do the 3x times x squared. So it's going to be 3 times, and then x times x squared. That's going to give us x to the power of 3. Remember that 3x is x to the power of 1. Then, plus, I'm going to do 3 times 4. 3 times 4 gives me the 12, and then I do the x times the x. X times x is x squared. And then plus 3x. If you have trouble remembering that little rule, you might want to make note of that on your paper someplace. X times x equals x squared. X plus x is the one that is 2x. We're next up going to be taking a look at describing polynomials. This can also be termed naming polynomials or classifying polynomials. Because polynomials can be described by 2 different ways. One of them is by what's called the degree of the polynomial. Degree of the polynomial, degree is just a fancy math word for saying the highest exponent of the polynomial. Why degree? Because mathematicians are lazy and they got tired of saying the highest exponent. So they decided to come up with some vocabulary to confuse you, just for fun. So, this is the information that you're going to need to have, though, for the degree of the polynomial. You notice the highest exponent. If the highest exponent in a particular problem is 0, then we describe that as a constant. If the highest exponent on the variable is 1, then we describe that as linear. If the highest exponent is 2, we call that a quadratic, and so on and so forth. All right, so now I want to practice these ideas. We're going to classify each of these 5 polynomials by degree. So we're going to go ahead and work these through together. So number 1. Remember, the degree is the highest exponent. So taking a look at number 1, what is the highest exponent there in number 1? So I look at the x's. What's the highest exponent on the x? 2. It is the 2. So then, I know my highest exponent is a 2. So what I'm going to do then is I'm going to go back to my picture. And I'm going to say, okay, if my highest exponent is a 2, I look in the table. That is called a quadratic. So this one then is a quadratic. All right, number 2. What is the highest exponent in number 2?
1.
And this one's kind of tricky because you don't actually see it written there. But yeah, that x is x to the power of 1. So this is a degree 1 polynomial. If it's degree 1, what do we call that? Linear. So we would describe this as a linear polynomial. Okay, number 3. What is the degree of number 3? Remember, that means that what's the highest exponent? So yes, it's 4. So the degree here is 4. Now this one can sometimes be a little tricky because we're so used to seeing the highest exponent first. But in this case, the highest exponent was actually put later. So the degree is 4. So then again, we go to our table and we say, okay, if the degree is 4, we call that a quartic. So this one gives us quartic. Number 4, -3. What is the degree of this one? Yeah, it's 0. If the x is gone, then our degree must be 0. And if we went back to our table, we would see that that means that it is called a constant. And the reason why it's named a constant is because since there's no x, no matter what you might claim x is, the answer is still going to just be a constant answer of -3. All right, and finally, number 5. What's the degree of number 5? Kind of a trick question here, by the way. The degree of number 5 is not 5. Which I know some of you are going, wait, what? No, clearly, the biggest exponent there is 5. Yes, but notice this can be simplified. Because I have an x to the 5th term here, and I have an x to the 5th term here. And if I combine those, 2x to the 5th minus 2x to the 5th is 0. That goes away. So really, this problem equals 8x cubed. I have to deal with categorizing it according to the simplified version. Because otherwise we could always add in extra stuff that would make it look like it was something else. So it's actually 8x cubed. So that means this is degree 3. And since it's degree 3, we would describe that as a cubic. So one way to categorize polynomials is by the degree. The other way is by the number of terms. So we're now going to take a look at categorizing it according to the number of terms. So if it has one term, it's called a monomial. If it's 2, it's a binomial. 3, it's a trinomial. If it's 4 or more, don't worry, we aren't going to get overly complicated here. If it's 4 or more, we just say it's a polynomial of that many terms. So for instance, if it has 4 terms, it's a polynomial of 4 terms. And again, you'll be able to keep seeing this information if you're still writing it down. All right, so we're going to practice this idea here. So with number 6, we need to start by counting the number of terms. Now, terms in a polynomial are anything that's separated by addition or subtraction. So in the case of number 6, I have a total of 3 terms. Because you notice there's 3 different parts of it that have been separated by addition. All right, so if there's 3 different terms, what do we call that? Well, 3 different terms, that would be a trinomial. Okay, number 7. Number 7, how many terms are there? Well, there's nothing separated by addition or subtraction, so there's just that one term, yeah. So if there's one term, what do we call it? Oh, interesting. If we just have the one term, there it goes. That's a monomial. All of these where we classify it by number of terms are some sort of a meal. Some sort of an omeal. So then this one will be a monomial. All right, number 8. There's a lot of stuff going on in number 8. So the first thing we want to do is see, can I simplify anything there? So are there any like terms that I can combine in number 8? No, it doesn't look like it. None of the exponents are the same, therefore there's nothing I can actually add or subtract. So then that means I got 5 terms. So if there's 5 terms, well, it's not exactly like a 5-nomial. We don't have anything like that. It is a polynomial of 5 terms. Okay, number 9. How many terms are in number 9? And again, we look to see divided by addition or subtraction. In this case, there are 2. So then this one will be a binomial. All right, and finally for number 10, what do you think number 10 will be? This one makes you think a little bit more, I hope. Can I simplify number 10 at the start? Yeah. So we want to do that first. So I'm going to look for like terms. And in this one, I actually have 3 terms that are x squared, or I'm sorry, x cubed, that we'll be able to combine. So 7x cubed plus x cubed, that would be 8x cubed. And then the 8x cubed we have minus that last 8x cubed is 0. So the x cubes all added up to 0. So really this whole thing is just negative 5x. That's the one I'm going to use to describe it by the number of terms. How many terms are there? 1. So since there's 1 term, this would actually be considered a monomial. Then we're going to practice this just a little bit more, where we're actually going to classify each of these by both the degree and the number of terms. I'm going to work the first one of these through with you, and then I'm going to give you a chance to work through the rest of them to see how well you got it. So on these, we're describing it by degree and number of terms. So first up, in number 11, what is the biggest exponent? 2. That is our degree. If we have a degree 2 polynomial, what do we call that?
Quadratic.
That is quadratic. All right, so that's quadratic. Then we're also classifying this one by number of terms. So how many terms are there here? Well, there's 1 term, there's 2 terms that are separated by that subtraction, so there's 2 terms. And if it has 2 terms, we call it what kind of omial? 2 is bi. So it's binomial. So we would then describe this as a quadratic binomial. We always do the degree part first and then the number of terms. Go ahead and work through the other 4. Okay, let's take a look at the rest of these. Number 12. First of all, we get our degree. What is the degree of number 12? 6, because that's our highest exponent. So degree 6 polynomial, that one is actually just called a degree 6. We're not going to worry about having crazy names for every single one of them. Once it's above 5, yeah, we'll just remember it's degree 6. All right, and then how many terms are there in number 12? 3. There's 3 terms. So that would be a degree 6 trinomial. Okay, number 13. What's the degree of our polynomial? If we just have an x, remember that is x to the power of 1. So it is degree 1, which is described as linear. And there's 1 term here. If there's 1 term, that means it is a monomial. So that is described as a linear monomial. Number 14. What is the degree of it? The degree here is 3. This one's kind of tricky because the 3 is not the start, where we normally expect to see the highest exponent. You do have to look through them. So this one's degree 3, which makes it a cubic. And then how many terms are there? 2 terms, so it is a cubic binomial. And finally, number 15. Number 15 does not look like the other ones. Well, anytime in math you see something and you're like, wait, this does not look like what I'm expecting to see, start by making it look like what you want to see. So the first thing I'll do here is I'll go ahead and distribute in that x to make it look like the others. So I'm going to do x times 6x squared. That is going to give me 6x cubed. And then I'm going to do x times 1. That is x. So this is then what I'm categorizing. I have 6x cubed plus x. Well, highest exponent here, the degree is 3, so that is cubic. There are 2 terms here, so that makes it a binomial. So this one is also a cubic binomial.